Okay, welcome to lesson 10-4, and let me get the lights. Okay, on 10-4, the perimeter and the area of similar figures. So what's our learning target? I can find the perimeter and the area of similar figures. So let's take a look at this. This box, Theorem 10.7, is really going to be the key to this lesson. So there's two things you need to really know and highlight here. The similarity ratio of two similar figures, if it is A to B, okay, A to B, then the ratio of the perimeter, or the perimeters, is still going to be A to B. And the ratio of the areas will be A squared to B squared. Okay, those are the two key things that we need to know. And let me show you kind of how that works. Let's begin with the first problem. Okay, example 1, ratio of similar figures. Okay, so if we look at the two trapezoids, you can see that we have a 6 to 9. That's the ratio of their sides, 6 to 9. The corresponding sides are 6 to 9, so that breaks down or reduces to 2 to 3. So what is the ratio of the perimeters? It's still 2 to 3. It's that simple. All right? So the ratio of the sides is going to be the same as the ratio of the perimeters. So if it's 2 to 3, the ratio of the perimeters will be 2 to 3. Now, what is the ratio of the areas? Okay, so let's look at what they do. Instead of doing 6 to 9, which you could, but it will reduce to 2 to 3, you want to do the ratio of the areas is going to be A squared to B squared. So A squared, so we're going to do 2 squared to 3 squared. So 2 squared is 4, 3 squared is 9. Okay, so we're just following this format. All right, so the ratio of the areas is 4 to 9. All right, example 2. All right, let's use the finding the areas using similar figures. Okay, the area of the smaller pentagon is 27.5. What is the best approximation for the larger of the area of the larger regular pentagon? Okay, so what's the ratio of their corresponding sides? It's 4 to 10, and that's going to reduce to 2 to 5. All right, so the ratio of the areas, your A to B, is 2 to 5. So remember back on your notes at the top that the ratio of the areas will be A squared to B squared. Okay, so we're going to take and square 2 squared to 5 squared. All right, 2 squared is 4, 5 squared is 25. So the ratio of the areas will be 4 to 25, small to large. Okay, so let's put that over here. 4 to 25 is going to equal this area of the small triangle, which we know to be 27.5, over the area of the large triangle. All right, let's cross multiply. 4x equals, okay, and on your calculator, 25 times 27.5 is 687.5. All right, and divide by 4, and x will equal 171.875. All right, and so the closest approximation to the area then, of course, is C. Okay, so again, to wrap that up, we did A to B was 2 to 5. So A squared to B squared turned out to be 4 to 25. So 4 to 25, it's small to large, and they told us the area of the small one was 27.5, and the large one we'll call X. And then just solve as a proportion. Okay, let's look at the next problem. Let's try to get this all on the screen here. The area of two similar triangles is 50 to 98. Okay, that's area, so it's a squared to b squared. All right, let's reduce that. What goes into 50? 2 goes into both of those, so 25 to 49. All right, so we have a squared to b squared is 25 to 49. What is the ratio of the perimeters? In other words, what is A and what is B? All right, I think you can see that a squared, if a squared is 25, then A is going to equal 5. And if B squared is 49, then B, the square root of 49, is 7. All right, so A to B is 5 to 7. And that concludes your notes for this lesson, 10-4. Thanks for watching.